So our step 1 is going to be to do what? Switch. So step 1, we're going to, not like that. Switch.
It can switch just like that, either way it says like.
What do you mean?
Like the y, it wouldn't matter if it says like the square.
Yeah, just the exit by itself. Yes, good question. So we're going to do that switch. So our y becomes the x. Oops, let me do that. So our y becomes the x, and our x becomes the y. So when you do this, you guys, the square stays there.
Oh.
It stays there. It does not follow with the x. And then plus our 2.
So just the x and the y just move up as its own variable.
Yes. Yes. Kind of pretty much independent of whatever else is there. Okay, now we're going to do what? Solve for y. Okay. So what's my first step? Subtract the 2. So I would have x minus 2 equal to 3y squared. And now what? Divide by the 3. We're going to divide the 3 out, aren't we? Okay. So the 3's will cancel. So I have an x minus 2. I'm going to go ahead and put that in parentheses over the 3 equal to y squared. Yeah, so think back what we did earlier. We need to square root it because squares and square roots are opposites, they're inverse of each other. All right, so we want our y, so we'll take the square root of both sides. So the square and the root cancel, so there's the y that we needed. And that will equal the square root of x minus 2 over 3. And how am I going to show that that is, in fact, the inverse?
The negative sign.
Yes, by our notation of f negative 1 of x equals that square root of x minus 2 over 3. Okay, so the first thing we're going to do is we're going to make that switch. So I'm going to put my x here, and then this would make this negative 3y plus 8, right? So we would subtract the 8. So we would have x minus 8 equal to negative 3y, and then we would divide out that negative 3, okay? So that would leave us with an inverse function of x minus 8 over negative 3. Okay, when you get into your higher math classes, they will not leave that negative in the denominator. So you'll want to do 1 and possibly 2 more steps after this. You're going to take that negative and you're going to move him out to the front. You must have your numerator in parentheses. Okay, so if you do that, then you would end up with negative and then parentheses your x minus 8 over your 3. Okay? So then if they wanted you to take it one step further, which would be to distribute the negative back in, then it's set up to go. Okay? Yeah. And then you can just, but we'll just leave it like this. Okay? Okay, let's look at our second one. Let's go with the different. Let's go with blue. All right, that was D. And D was the f of x equal to 3x minus 2 over 6. I chose this one specifically because of that denominator, because we remind us how we work with those. So let's do our switch. So x would be equal to 3y minus 2 over 6. So when we have equations that have denominators, what do we like to do first? Multiply that denominator. We want to get rid of it, right? I'm like you. I don't necessarily want to work with the fractions, right? So if I can get rid of them, I'm going to. So those would cancel. So we would have 6x equal to the 3y minus 2. And now we're ready to just solve it. So we would add our 2. So 6x plus 2 equal to the 3y, and then we will do our division. Okay? So that would give us our inverse. So we're going to use our correct notation. So 6x plus 2, I'm going to go ahead and put that parentheses so I'm not tempted to maybe divide that 6 and 2 because I really can't do that. Okay, over my 3. And that one we're done with. Okay? All right, I'm going to take that, our notation here, and I'm just going to change that to g of x, okay, just so it's a little bit easier to write and it's kind of more what you're used to. But remember, these are inverses of each other, okay? So we're going to start. Which one do you want to put inside first? You care? All right, let's do this. Let's put the g inside of the f. So let's compose f of g of x. All right, so our g of x is really the inverse, so that's this guy. We're going to put him in right there. I can compose him right there. So that would be 2 times all of our g of x, which is the x plus 4 over 2. And then minus that 4 that's in our f of x. Okay, so let's simplify this down, kind of like what we did over there on the board. We're going to simplify it down. First thing I'm going to do is I'm going to put the 2 over a 1, so I know that's a fraction. I need to, since I have fractions already. What can I do? Do you see something we can do?
Cancel out the denominator.
Yeah, that 2, that denominator of 2 and the other 2 will cancel each other out. Very good, thank you. So what would that leave us with then? That would leave us with x plus 4 and then minus 4. Now what can we do? Yeah, you see it? 4 minus 4? So what? Yes, so we're left with just x. All right? That's what they're talking about. When you simplify it down, inverse functions will cancel each other out, and you'll only be left with that input, in this case, the x. All right? Let's do it again. So now we're going to do g of f of x. So now we're going to put f into g. So now we're going to put all of this, all of our f of x, and we're going to go all the way over here, and we're going to put it right in there for the x. Okay. So what's that going to be? That's going to be a 2x minus 4. We put all that in for the x, but we still have that plus 4, and we still have all of that being divided by 2. Okay, let's simplify this down. What can I do in that numerator? 2x minus 4 plus 4.
You can cancel out the 4.
I can cancel out the 4s. What will that leave me with?
The 2x divided by 2.
2x over 2.
Where'd you get the 2x plus 4?
Yeah. Now we can do what? Okay, 2's will cancel. And, well, what are we going to have left? So what does that tell us? They are true inverses of each other. You are correct. So, we would say that, yes, they are inverses. We have proven it. Okay. So, first one we're going to do is, we'll do the f of g of x. So I'm going to take the g of x, and I'm going to put that in to f. So that would be 2/3 times, and put all that in, 3/2 x minus 9, and then plus the 6. All right, so the 2/3 times the 3/2. 2/3 and 3/2 are reciprocals of each other. You multiply those together and you get what? 2/3 times 3/2, you multiply those together, you get a 1. So that's going to be your 1x.
Oh, okay.
All right, 2/3 times the negative 9. Put your 9 over 1. 2 times 9 is 18. Divided by 3.
6.
So it'd be negative 6. plus 6. Cancel out. What are we left with? X. So that one works. Let's do the other one. So now we're going to put the f of x into the g of x. See if we can get it done. So that would be the 3/2 times the 2/3 x plus 6 minus 9. All right, again, hey, stop moving. The 3/2 and the 2/3 equals what when you multiply them? 1x. Okay, the 3/2 times the 6. 6 times 3 is 18 divided by 2 is, so plus 9 minus 9. Cancel, and we're left with, all right, so what's our answer? Our answer is yes, they are. Okay?